can do ourselves a bit of an exercise, a coding exercise. So the main aim is that we're going to try building our gradient descent model from scratch, and I'm going to show you lot how this kind of works. So the first thing we need to do is that we need to import our dataset and libraries. Normal stuff, we need to import our pandas, our numpy, our matplotlib, our scikit-learn. So the reason why we're importing scikit-learn is to get our breast cancer dataset, our train test split, our standard scalar, and our confusion matrices and stuff. So just a quick reminder, we're not actually training our model using scikit-learn, although you can do that. The main aim of this exercise is to show you lot how gradient descent would have worked mathematically. Regardless, let's move on. So once we've imported our dataset, we need to get our dataset essentially. So we're going to say that our cancer data is, we're going to use the load breast cancer from model, and we're just going to use as frame to be true. So once I run that, you can get that. And the next thing we're going to do is that we're going to get our data frame, and our data frame, we're going to take the cancer data and we're going to frame it. And if I just do this, you can see that we've got all of our data, and you can see that we've also got our targets. The next thing we are going to do is that we are going to make our x's and y's. So what I mean by that is that I want our vector x to be our set of features, our set of data, and our y to be our targets. So what I mean by that, if I look at x, you won't really see the target values themselves, and if I take the value of y, you can see the target values themselves. So that means, so that's what our values of x and y are doing. The next thing that I also like to do is to actually just see the shapes of my data. So we can see that our x shape is 539 by 30 and our y shape is 539, and the reason for that is because the original thing is 539 times 31, but one of our data set is the target itself, so that's why it's 539 by 30, and our classes are malign and unbenign as talked about before. The next thing we are going to do is that we're going to do our train test split. So what we are train test split, so what this does is that we have our training data, our testing data, and our training data, our testing data as well. So what this allows us to do is that we can test our model later on and prevent overfitting and stuff. So just to show you lot what this means, our x is our features, our y is our target, our test size of 0.2 means 80% is going to go to the training data and the remaining 20% is going to go to the testing data. The random state of 42 means that if I was to rerun the cell again, it will train test split the shuffle the same way. And stratify of yes means that both our training data and our testing data, they will have the same number of malign and benign cases. The next thing what I'm going to do is I'm actually going to run it first of all. The next thing I'm going to do is that we need to standardize our features. So what standardize our features basically means is that all of our features should have a mean of 0 and our standard deviation of 1. So what this allows us to do is to make sure that all features are given equal importance, essentially. The next thing what we're going to do is that we're going to create our model from scratch. So let's create our model from scratch. The first thing I'm going to do is that I'm going to create my object called the class, and I'm going to call it a regression from scratch. And I'm actually going to remove this because I don't like how this is right now. Okay. Next thing we're going to do is that we're going to create our initialized function. And we can say that our learning rate is 0.01 and our iterations is 1000. We've got our learning rate, we've got a number of iterations. And I'm actually going to remove this because I'm going to do it in a much more cleaner way, that I believe. If you remember that what our theta values were, or what theta actually is doing, you remember that theta is our parameter vector, and the first part is our bias, and the remaining things are the future weights. Next thing what I'm going to do is that I'm actually going to create an add bias column. So an add bias column. So what this will allow us to do is to manipulate the x values themselves. the x, sorry, not values, the array itself. So what this will allow us to do is that we can create our values of ones, which is going to be in the shape of zeros and 1. So what this means is that we're going to have our ones, that's going to be x shape 0 long, and it's going to be just 1 column wide. And what I'm going to do is that I'm going to create our h stack, and I'm going to return it. So what a h stack does is going to be a horizontal stack. So the first thing we're going to have is our column of ones and the values of x's themselves. The next thing I'm going to do, we're going to have a sigmoid function, and what I'm going to do is that our z, I'm going to clip it from minus 500 to 500, and I'm going to return the exponential function. The next thing I'm going to do is I need to create my binary cross entropy loss, and I'm saying that my epsilon is 1 e to the power of minus 15, and we're going to create our predicted values, and then we're going to return the binary cross entropy formula that we've seen in previous episode. The next thing I am going to do is I'm going to create the fit. So define fit. So what this means is that the first thing we are going to do is that we're going to create our x, which is going to be our np array, or sorry, np as array, and that's going to be x, and it's going to be a d type of, it's going to be a numpy array. And the same thing I'm going to do with my y as well. The next thing I'm going to do is I'm going to do some checks. So if I want to say that if my x dot dimensions, you know, they aren't 2, then I'm saying that x must be a 2D array. And the next thing I'm going to check is that if my x dot shape 0 isn't the same as y, then we know that our samples aren't created equally. The next thing I'm going to do is I'm going to create my x augmented, and what we're going to do is that we're just creating our bias column. So what this allows us to do is that it's going to allow us to have a column of ones and all of our features. Next thing we need to do is that we need to create our number of samples and our number of parameters. The number of samples is just going to be the shape 0, and the number of parameters is just going to be the number of features itself. Next thing that we need to do is that we need to create our theta vector. So just a reminder, theta has a bias and then all of our weights, and then self.theta is our numpy of zeros, which is the number of parameters. And then what I'm going to do is that I'm going to recreate my loss history. Now, next thing we need to do is that we're going to create our iteration. So we can say that for iteration in range, and we're going to take this, we're going to iterate this, our n iteration amount of time. First thing that we need to do is that we need to get our linear score. So our linear scores we can think of is going to be x theta. So x multiplied that by, sorry, not x augmented, multiply that by my self.theta. And the next thing we need to have is that we need to have our probabilities, and that's going to be the sigmoid that's passed. It's going to be a sigmoid function. The next thing what I'm going to do is that I'm going to create my loss, and my loss is going to be my binary cross entropy, which is my y and my probabilities, and then I'm going to append my loss. And then I'm going to append my loss. The next thing I am going to do is that in the same function, in the same for loop, is that I'm going to create my gradient, and I think I've just misspelt stuff. I'm going to create my gradient. So next thing is, if I just kind of say gradient, my errors is my probabilities minus y. My gradient is, my gradient vector is going to be all of this. Yeah. And for some reason, I just need to move this around. And have I spelled errors the wrong way? Errors. Yeah. I just want the errors. Yeah, that needs to be an S. Next thing that we need to do is that we need to create our gradient descent update. So we can say the gradient descent update. And that's just going to say that our theta parameter is going to be the learning rate multiplied by the gradient itself. And what I want to do is I want to say that if my iteration divided by 100 is 0, I just want to show the iteration and the loss itself, not after every value, otherwise it just looks a little bit tiresome. But I think what I'm going to do is I'm going to create my predict probabilities. And that's going to take in my values of self and my values of x. And the first thing I need to check is if my self.theta is none, then that means that our model hasn't been fitted yet. Should be is, should be if. Else. Now the next thing I want to do is that I want to create an x, which is going to be my numpy array, and I want to create my x augmented again, which is going to be my bias column. I want to create my linear scores, and then I want to create the return self.sigmoid linear scores. The next thing I want to do is I want to create a predict function. So we can say define predict, and we're going to say our self, our x, our threshold of 0.5. Our probabilities is going to be, we're going to predict our probabilities, and then we're going to return it by saying that if our probabilities are greater than 0.5, it's going to be 1, otherwise we're going to predict them to be 0. Now I'm going to create a couple of helper functions, and we're going to say we're going to define our bias, and our bias is just going to be that. And the next thing we also need to create is the weights themselves. So we can say that define the property, and I'm just going to have my weights as well, and then hopefully this all runs. And I just have an unexpected indent somewhere. Where is it? Why is my indenting there? Should be about... where should it be? It should be right there, right? Self.theta. Why is this happening now? 1 second. Yeah, so we've just solved the indenting issue and everything seems to be fine. We've created our model architecture. The next thing that we need to do is that we need to train our model. And the way we are going to do that, is that we are going to say the following lines. Give me a moment. We're going to say that our model is going to be a logistic regression Sratch. We've given it a learning rate and an iteration, and we're going to train the model. And then you can see here, what it's doing is we can see our losses are becoming incredibly more smaller. So that's a positive sign, first of all. I think another thing that we could also do is that we can also look at the accuracy. So let's look at the training accuracy, and then training accuracy. Can I don't think I spelled it right. Yeah. So we'll take our train accuracy and our test accuracy, and the next thing, and then I'll just kind of print just nothing, I'll create a report essentially, and then we can say our test predictions. And has no attribute accuracy. And I think the reason why is because I haven't created my accuracy thing yet. I believe I haven't created my accuracy. So what I will do is we've created our predict probabilities, and we've created a predict. I need to create my function accuracy, don't I? So what I will do is I will just create my accuracy right now. Do that sort of create this over here, and then move this down over here, and then do all of this, and then do all of this, and then you can see over here our results. So you can see that our malignant is about 95% precision, recall 98%, and our benign looks pretty good. And then we can see over here our training accuracy is 98%, and our testing accuracy is 97%. I think another thing that we can also have a look at is actually we can plot our loss. So what I'll do is I will do a PL2 figure, and then we'll plot the model loss history, which is our array. The X label will be the gradient descent iteration, and then the Y label will be the bounding cross entropy loss. So if I just show you what this looks like, you can see that the bounding cross entropy loss is getting better and better and better. And that's exactly why gradient descent kind of works, and why we are getting all these high accuracy results. It's just simply because of gradient descent. This is the algorithm that teaches machine learning models to learn. I think this is it. This is what gradient descent is. So if you enjoyed that video, like, comment, share, and subscribe. I'll see you in the next one.